I welcome you to this lesson number 7 in our equations series, where we are continuing on the second method on simultaneous equations, which is the elimination method. You'd realize that this elimination method works better when the coefficients of the unknown are greater than 1. You shall see that these are the instances where we cannot rearrange without creating this fraction. So we cannot change to make a subject of the formula as we were doing in equations like this, where x and y had a coefficient of 1. You'd see now that the unknown has got a coefficient greater than 1. For example, here the coefficients of m are 5 and 3, right? So if we attempt to make any of these two is the subject of the formula, we would create a fraction. For example, here on the first equation, it would be like 5m is equal to 15 plus 2n, and you divide both sides by 5, which becomes a fraction, and it becomes a very long way to do to solve our problem. So in these instances, we use elimination, which refers to the removal, right, or the exclusion of one variable as we use it in mathematics, right? So we exclude one unknown variable, and we solve the remaining variable. So here we may exclude m and start with this one, right? So we use addition and subtraction, right? You see that these two equations either subtract or add to each other, right? But I want you to pay attention to these signs, because they determine whether you pass or fail these, if you remember directed numbers very well. Now, having said so, let's have this illustration here, right? What we have to do first is to equate either these m variables or these n variables. But for now, let me equate these ones which have got the same sign. It's plus 5m here and it's plus 3m here, right? So what do? We multiply these to balance them. How do we make this number the same as this number here, right? We would simply multiply here everything. In this first equation, we multiply by these 3 that you are seeing there, and here we multiply by this 5 that you are seeing here, right? So it's a matter of that which is at the top multiplies that which is at the bottom, and that which is at the bottom multiplies that which is at the top. Now from there, you are now multiplying every equation by the corresponding figure. This is what you get. So 5m times 3, you get 15m, minus 2n multiplied by 3, you get minus 6n, then 15 multiplied by 3, you get 45. You do the same on the second equation. Now we introduce 3 minus signs. Why? Because we want to eliminate, to remove. If you can see here, it's 15m, here it's 15m. These two variables have been equated. They are now equal. So if you subtract them, you should get a 0. So you introduce 3 negative signs like this, right? Why do I say so? So that you don't forget. If you introduce 1 here, you would forget to say minus 6, minus 25, right? So here is, say, 15m minus 15m, you get a 0. Then you can ignore this 0 again. It's irrelevant. So minus 6n minus 25 minus 6n minus plus 25 minus times plus, you get minus here. Minus 25n is equal to 45 minus 45, which gives you another 0. So the answer that we'll be looking for is minus 31 is equal to 0. So n is equal to 0. We go back to substitution that we taught in our previous method, right? So in that we are now substituting any equation 1 or 2 with 0, right? As you can see, 3m plus 0 is equal to 9. So 3m is equal to 9, and m becomes equal to 3. We may also do this another example that we have here. We are still equating those that have got a positive sign only, right? So we want to equate this one. So you may pause if you have understood our first example, then play again to see if we are together. Now we multiply by 7 at the top and we multiply by these 3 at the bottom. So these are the answers that we get, right? From there we subtract so that we eliminate this x, right? So and we now have 14y minus minus. Pay attention to those two minus signs is equal to 49 minus 3. So what do we get? We get these two signs change to become plus, right? And this is what we have. 23y is equal to 46. So dividing both sides by 23y is equal to 2. We now substitute again till we get our answer, which is x is equal to 1. The good thing about mathematics, especially equations, is that you can cross-check if your answer is very correct. So where there is y, you put this 2, and where there is 1 x, you put this 1, and see if you get this 7. Right. You may now pause and solve this particular problem that we have. Right. So your answer should become, by eliminating a, you would multiply by 5 here and by 3 here. You do subtract this, what you can subtract, and you come to this stage whereby minus 10b minus 12b is equal to 35 minus 24. Right? You further subtract and you say b is equal to minus half. You substitute again in another equation, and this is what you get. 2 into 2, they cancel each other. They minus 1 multiplied by minus 1, you would get plus 1. So 3a is equal to 6a is equal to 2, and we are done. But then you should also know that there are instances like this. If you can solve this one again, you may pause and solve this one. Right. I want you to take note of the fact that if you look very carefully, you would see that 2y and 2y are same, are equal, are already equated. So I do not need to first multiply by any other number because they are already equated. So what I will start by introducing my negative signs there. This is what I do. I continue. 4x minus 2. Here it's coming from here. 4x minus 2. X is equal to 22 minus 2. So 6x is equal to 20. This is our answer. Now substituting in any of the equations, you would come to that. You would multiply both everything by 3, which is the LCM. You would cancel there, and this is what you get. 40 plus 6y is equal to 66. This is what you also get. 6y is equal to 26, and y is equal to 13 over 3. Right? Right. We may proceed. Having said we were equating those with the same sign, the positive sign, sometimes there would come those who one variable is a negative and one variable is a positive. So what do we do? For example, in this particular instance, we have got minus 3d and plus 4d. Right? What do we do? As usual, that which is at the bottom multiplies that which is at the top for your for the value that you want to eliminate. So here I multiplied by 4, here I multiplied by 3. Right? I'm now dealing with these ones at the middle. They've got different signs. Here it's a minus, here it's a plus. Now from there you would see we are now multiplying. Right? Now there is minus 12d and plus 12d. How do we solve it? Now, given that these are different signs, you have equated the variable which has got different signs. You do not introduce the minus signs. Rather, you introduce 3 positive signs. Right? So here we are adding, right? So when you would see, so the difference between those that we're doing is that when we equate those with positive signs, we introduce negative 3 minus signs. But if we are equating those with different signs, we introduce 3 positive signs. Right? So what happens here is you would see plus 12d plus minus 12d. Right? You would get a 0. Or even if you say minus 12d plus 12d, the answer still remains a 0. So 16c plus 6c is equal to 4 plus 51, which is 55. From there 22c is equal to 55. We divide both sides by 22, that one cancels that one, and we reduce this one to its lowest terms. So by dividing by 11 we get a 2, and dividing by 11 here we get a 5. So c is equal to 5 over 2. We substitute, and this one cancels that one again, and we remain with this. So we solve that amicably. You may pause and again solve this one. First things first, we multiply to equate our unknown variable, right, which we are dealing with here, with their different signs. From there you would see we have multiplied. We now have minus 8b plus 8b. We introduce our positive signs. From there you would see 12a plus 10a is equal to 28 plus 16, which gives us that number. A is equal to 2 by dividing both sides there, and we substitute 3 multiplied by 2, get a 6 minus 2b, which gives us that answer. So minus half is equal to b. You can cross check our second illustration in this lesson. You would see we also got these answers. Now you may solve this one. Your answers should become like this. So having equated these ones, right? So our last illustration is this one. Using any way you want to equate, either this one or this one, make sure your answer should become like this, right? Lastly, our exercise is there. So solve these 4 problems and submit. From me, the lecture ends here. You may contact me on these numbers for any clarifications.